Let us talk about domain and range in equations. So number 1, y is equal to 2x. To determine the domain, solve for y. Our only restriction here is if we will be having a denominator. The denominator must not be equal to 0. So y is equal to 2x. We do not have denominator here. So therefore, we don't have restriction. So our domain is from negative infinity to positive infinity, or set of all real numbers. To determine the range, let us solve for x. So again, our restriction is the denominator must not be equal to 0. So y is equal to 2x. To solve for x, we divide both sides by 2. So this will become x is equal to y over 2. We have a denominator here, but it is not a variable. It's a constant. So there is no value that can make our denominator 0. Again, we do not have restrictions. So our range is from negative infinity to positive infinity. Let us have another one. Negative 2x plus y is equal to negative 8. To determine the domain, let us solve for y. So negative 2x plus y equals negative 8. Moving negative 2x to the other side, it will become positive. So y equals 2x copy minus 8. Again, we do not have denominator, so no restrictions. Our domain is negative infinity to positive infinity. For the range, let us solve for x. So negative 2x plus y equals negative 8. Let's move y to the other side. Negative 2x minus y copy minus 8. Let us divide both sides by negative 2. So this time we have a denominator, but again, this is not a variable. It's a constant, so no restrictions again. So our range will be the set of all real numbers. Number 3, y minus 1 is equal to x squared. So this is actually quadratic. To determine the domain, let us solve for y. So let us move negative 1 to the other side. Y equals x squared plus 1. We do not have denominator, so it means we do not have restrictions. So our domain is the set of all real numbers. For the range, let us solve for x. So y minus 1 is equal to x squared. Let me switch the position. In solving, we are used that the unknown is at the left side. So let us take the square root of both sides. This will become x equals the square root of y minus 1. Since I have a square root here, the value of my radicand should be greater than or equal to 0. Because if this is negative, the square root of negative is imaginary. So all we have to do is to set our radicand greater than or equal to 0. Moving negative 1 to the other side, y is greater than or equal to 1. This will now be our range. Now, how do we write that in interval notation? So you start from 1, going to positive infinity. There is or equal, so we make use of bracket. 1 to positive infinity. Number 4, y is equal to 3x squared minus 4. This is actually a quadratic function. And if it is quadratic function, the domain is always the set of all real numbers. Now for the range, let us solve for x. So y is equal to 3x squared minus 4. Let us move negative 4 to the other side. Y plus 4 equals 3x squared. Let us switch places. And then we divide both sides by 3. So we have x squared is equal to y plus 4 divided by 3. Then take the square root of both sides. So this will become x equals the square root of y plus 4 over 3. Then we set up our radicand greater than or equal to 0. To eliminate this 3 here, let us multiply both sides by 3. So this 3 will be cancelled out. Then 0 times 3 is 0. So you have y plus 4 greater than or equal to 0. Move positive 4 to the other side. Y is greater than or equal to negative 4. This will be our range. Now, in interval notation, you'll start with negative 4 going to the right. So from negative 4 to positive infinity. Why bracket? Because there is or equal to. Number 5, y is equal to the square root of x minus 5. So this is a radical function. So to determine the domain, let us just set the radicand greater than or equal to 0. So we have x minus 5 greater than or equal to 0. Let's move this to the other side. X is greater than or equal to 5. This will be our domain. So for interval notation, you'll start with 5 and then going to the right. So that means 5 to positive infinity. So because there is or equal, we'll make use of bracket. Now for the range, let us use the limits of the domain. Let's start with the lower limit. So let's copy the function and then we substitute our lower limit, which is 5. So y is equal to the square root of 5 minus 5. Y is equal to 5 minus 5 is 0, is square root of 0. And square root of 0 is 0. Now for our upper limit, let's copy the function again. And this time, let's substitute positive infinity. So y is equal to the square root of positive infinity minus 5. A very big number minus 5 is still a very big number. And a square root of a very big number is still a very big number. So our lower limit is 0. Our upper limit is positive infinity. This will be our range from 0 to positive infinity. So in set builder notation, that would be values of y that are greater than or equal to 0. Number 6. Y is equal to negative square root of 10 minus 2x. So for the domain, let's set our radicand greater than or equal to 0. Let's move 10 to the other side. So we have negative 2x greater than or equal to negative 10. And then we divide both sides by negative 2. Negative 2x divided by negative 2 is x. Negative 10 divided by negative 2 is positive 5. But since we divide by a negative number, our inequality symbol will change. So final answer, x is less than or equal to 5. This will be our domain. So our domain, 5 going to the left. But since we write from a lower value, this will be from negative infinity to positive 5. So there is or equal to, so you'll make use of bracket. Now for the range, let's use the limits of the domain. Let's start with the lower limit. So we're going to substitute negative infinity for x. So we have y equals negative is square root of 10 minus 2 times negative infinity. So 2 times negative infinity is still a very big negative number. But negative of negative will become positive infinity. So y equals negative is square root of 10 plus infinity. And 10 plus a very big number is still a very big number. So y equals negative is square root of infinity. And square root of a big number is still a big number multiplied by negative. So you have y equals negative infinity. Now for the upper limit, let us substitute 5 this time for x. So y equals negative is square root of 10 minus 2 times 5. 2 times 5 is 10. So 10 minus 10 is 0. So y equals negative is square root of 0. And square root of 0 is 0. So y equals negative 0. But we do not have negative 0. So y equals 0. So our lower limit is negative infinity and our upper limit is 0. So from negative infinity to 0. So in interval notation, this will be values of y that are less than or equal to 0.